Long before modern technology reshaped daily life, humanity dared to send a small machine far beyond the comfort of Earth. In the late 1970s, a spacecraft was launched with a bold purpose: to explore the distant edges of our solar system and uncover secrets hidden in the darkness of space. That spacecraft, known as Voyager 1, carried with it not just scientific tools, but the collective curiosity of an entire species. At the time, the world was very different. There were no smartphones guiding people through their days, no internet connecting billions instantly. Computers were massive and limited, yet engineers managed to design a machine capable of surviving one of the harshest environments imaginable. Every component had to work flawlessly, because once it left Earth, there would be no second chances. The mission's primary objective was to study the outer planets up close. As the spacecraft traveled outward, it encountered massive worlds that had only been observed from afar. When it flew past Jupiter, it revealed a turbulent atmosphere filled with enormous storms, including the famous Great Red Spot. Later, it reached Saturn, capturing breathtaking views of its rings, vast structures made of ice and rock, moving together in delicate balance. These encounters reshaped scientific understanding. What were once distant points of light became complex, dynamic worlds. The data sent back changed textbooks and expanded human knowledge about the solar system. Even after completing its planetary mission, the spacecraft did not stop. It continued moving outward, venturing into regions no human-made object had ever explored. Over time, it became the most distant object ever created by humanity. Eventually, it crossed a boundary called the heliopause, a region where the influence of the Sun fades and interstellar space begins. When it entered interstellar space in 2012, it marked a historic milestone. For the first time, a human-made object had reached the space between stars. Before this, many believed that region to be silent and empty. But the spacecraft told a different story. Its instruments detected faint energy, subtle vibrations, and shifting patterns. These findings showed that interstellar space is not still. It is active and constantly changing. It also recorded sudden increases in particles, suggesting powerful events happening far away. Some of these signals may be linked to distant supernova explosions, where massive stars end their lives in bursts of energy that echo across the galaxy for millions of years. The spacecraft also observed magnetic fields behaving in unusual ways. These invisible forces can guide or block particles, sometimes forming boundaries that act like barriers in space. When it crossed one such region, it detected an unexpected spike in activity, proving that the edge of the Sun's influence is not smooth but sharp and complex. Even after decades of travel, the spacecraft continues to function, though time has taken its toll. Its systems are aging and occasional issues appear. At one point, engineers received confusing data caused by a damaged memory section, likely the result of a high-energy cosmic particle striking the spacecraft. By then, it was nearly 15 billion miles away. Communication at such a distance is incredibly slow, with signals taking nearly a full day to travel one way. Despite this, scientists carefully send commands and patiently wait for responses, keeping the mission alive against all odds. Today, this spacecraft stands as a powerful symbol of exploration. It represents humanity's desire to go beyond limits and understand the unknown. One day, its power will fade, and contact will be lost. But the spacecraft itself will continue drifting through the galaxy for millions of years, carrying a small piece of Earth into the endless cosmic ocean. As the journey continues deeper into interstellar space, the spacecraft carries something far more meaningful than just instruments and data. Attached to its body is a unique object known as the Voyager Golden Record. The idea behind this record was simple yet profound. If the spacecraft is ever found, it should tell the story of who we are. It contains sounds, images, and music representing life on Earth. There are greetings in multiple languages, natural sounds like wind and rain, and even the laughter of a human being. It also includes music from different cultures, showing the diversity and creativity of our world. Among the contributors to this project was the renowned scientist Carl Sagan, who played a major role in selecting the content. The record was designed not just as a scientific message, but as a cultural time capsule, a snapshot of humanity at a particular moment in history. Instructions for playing the record were also included, engraved directly onto its surface. These instructions use universal scientific concepts, such as the structure of the hydrogen atom, to guide whoever might find it. Even the location of Earth is encoded using pulsars, rapidly spinning stars that act like cosmic landmarks. As Voyager 1 travels farther away, it becomes increasingly isolated. The signals it sends back grow weaker, and the energy powering its systems continues to decline. Scientists have already begun shutting down non-essential instruments to conserve power. One by one, its capabilities will fade. Eventually, sometime in the coming years, the spacecraft will fall completely silent. It will no longer be able to communicate with Earth. But that will not be the end of its journey. Long after its systems shut down, it will continue drifting through the galaxy. It will pass by distant stars over unimaginable timescales. In about 40,000 years, it is expected to come relatively close to another star system, though close in space still means a vast distance. Out there, without guidance or control, it will move silently through the cosmic darkness. It will not return, and it will not be recovered. Yet it will remain intact, a small but enduring trace of human existence. There is something deeply powerful about that idea. A fragile species on a small planet managed to build a machine capable of leaving its home forever. Not for conquest, not for survival, but for knowledge and discovery. The spacecraft's journey also raises questions that go beyond science. If another civilization ever finds it, how will they interpret its message? Will they understand the sounds, the images, the emotions encoded within it? Or will it remain a mystery, just as much as the universe itself is a mystery to us? In many ways, this mission is not just about space, it is about identity. It reflects how humanity chooses to present itself to the unknown. It shows what we value, what we create, and how we see our place in the universe. Even now, as it moves farther into the darkness, the spacecraft continues to represent a connection between Earth and the vast cosmos. It reminds us that exploration does not end at the edge of what we know. Instead, that edge is where true discovery begins. And somewhere out there, beyond the reach of sunlight, beyond the boundaries of our solar system, this silent traveler continues forward, carrying a story that may never be heard, yet will exist for as long as the stars themselves endure. As the distance between Earth and the spacecraft grows beyond imagination, something unusual begins to happen, not in the machine itself, but in how we think about it. The mission slowly transforms from a scientific project into something almost philosophical. It is no longer just about data or discoveries. It becomes a reflection of humanity's place in the universe. Out in the vast darkness, far beyond the reach of the sun, Voyager 1 moves through a region where time feels different. There are no familiar landmarks, no planets, no guiding lights, only distant stars scattered across an endless void. Yet even in this emptiness, the spacecraft continues to encounter subtle signs of activity.